Pacific. The data is in adjusted mode, but it's adjusted quite erroneously high. There's a gain of 1.61 applied. I don't know. I have some theories on how that happened, but it's not really important for the moment. Important to know about that is because the current adjusted value is so high, it appears in the oxygen audit, which I will leverage. And I get a mean gain of 1.050 on my first pass of it before I even look at any of the data. So on the right here is my code to get this gain off the start. I'm importing some packages for plotting and date handling, and here's mine down here. This is my WMO number. I want you to pay particular attention to this line where I load, so this is my package, BGC. I'm loading the synthetic profile into this object that I'm calling float. This is going to be sort of our workhorse. Everything's going to come off of this. And then I'm doing float.clean, which effectively is getting rid of anything that's a flag 4. I don't want to work with bad data. There might be a reason that I want to see the bad data later, and we'll come to that. And then I am calculating the gains and printing them out, and this is what I get. And so, yeah, I grabbed a screen cap from the fleet monitoring. This is where the float is, and so on. Like I said, this does appear in the audit. A lot of it is flagged because there's a bunch of really high DOXY adjusted, some gain that shouldn't have been applied, I think probably was. But the raw gain, and this is not a direct comparison because it's not all the profiles, but the mean gain of the raw oxygen in the audit is 1.047. So we're in the, Josh and I are in the same atmosphere off the start. This is the code that I used to check my audit file. Not super important for the package, but I'm trying to be complete. So let's plot here. I'm going to jump back and forth, actually. This is the panels here, very similar to what you would get out of SAGE. I've got the blue line is our float mean in the top 25 meters. You could set that to be a different depth interval if you wanted to. And then our orange line is our World Ocean Atlas data. And then these green faded dots in the back are just all the data that goes into this blue line mean from the float. You can see there's a couple profiles off of this that we might want to take a look at. This one in particular is giving us a really high gain, something going on here. And this sort of this line here is at least a little suspicious to me. Briefly, I'll go through this again. This is our code to create that plot. And so this is our float object that we loaded our synthetic profile into. And I want to see a gain plot, and I want my reference to be World Ocean Atlas. If it was a float with in-air data, this could equally be NCEP, and you would see that. And then down here, I'm saving this figure so that I can put it in my PowerPoint later. Yeah. This is another plot. You can probably guess what QC Profiles is doing based on this down here, but just a few observations about this plot. It is showing by color what the QC flag is. So this is an older float, and dissolved oxygen should all be 3 in its raw form by default, but it's a float that hasn't been reprocessed to show that yet. But this is also highlighting, so clearly something happens with the salinity, and these core files are in D mode. And so clearly something happens with the salinity, and we see that our oxygen, because that is the real-time procedure, is 3, while salinity is 4. And then on the right here, I've just brought this up to the top 200 meters, because that's the area that we're going to be more interested in. If you guessed that these two profiles are our outliers that we saw on the gain plot, you are correct. And so something I want to talk about here, I suppose, is if you were to use this as I am for visual QC, it is a little clunky right now to pick, okay, I want to, you know, mark these particular ones as 4. You kind of have to come up with like something that makes sense in programming language for how to define, you know, grabbing these 2 profiles. Some like interactive plotting, there's some good packages for that in Python to just sort of like open up an interactive window and click on these points and return something that is informative to me is something that's on my radar. It's what that linked issue there is. But for now, this is how I've described these 2 cycles. I'm looking for these ones that have quite low oxygen near the surface. And it shows me that cycles 61 and 190 are those. And so then this is none of this on the right. Again, I've put this here for completeness, but none of this on the right has anything to do with the DMQC package, except for the fact that the data is coming from it. But the rest of this is just core Python, sort of typical plotting you would see. But just I made a new plot because I felt that the last one didn't show me these profiles clearly enough, and so I wanted to take a look at them. This is where I made my decision, and certainly also where I would take some feedback as a perhaps more novice DMQC operator, that I said, okay, I'm going to say that, you know, these profiles don't look like they're totally bad. And I maybe even could have gone a little further up, but I threw out anything that was shallower than 300 meters for these. I didn't think that the surface measurements looked reliable. If we went back to the map, this float wasn't really moving around a lot, so I don't think it like went into a new water mass suddenly and then immediately back to the other one. So these points seemed like something else going on, perhaps not the proper oxygen, and so I'm going to remove them. And so if I want to remove them, there's a function called update field. I'm still working on my, you know, this float object that we've had from the beginning. And then after I update my oxygen QC to be 4, if I call on this float.clean again, it's going to get rid of those data and I can redo what I did in the first place. And so if I throw those out, it does move our mean gain a little bit. And also the plot looks much nicer because we're not all scrunched up on the axes. And so this is what we end up with when I reproduce this plot from earlier. This looks pretty reliable to me, pretty happy with it. I feel good about going ahead and applying this gain. And so I'm going to talk now about, now that we've removed those bad values, calculated a gain that we're deeming reliable, let's go make my delayed mode files, essentially. So I don't know if before we get into that, if anyone, I haven't seen chat or anything like that. So if anyone wants to point a question out to me before we get into that, feel free to just pipe up. But otherwise, I'll show these. And some of what I do here is redundant in the flagging, but that makes me feel safe. And so, like I said, oxygen should be flagged as 3 by default. This float was not in some cases, and so I am fixing that. I'm saying make my DOXY 3 if it is currently 0, 1, or 2. Then I'm going to apply the gain. So I'm saying update field, I want deoxy adjusted to be populated with my gain times my raw deoxy. And when I fill my adjusted field, I have to fill my adjusted error field. And so I'm saying update this error field with a fixed error. You could define what the number is in here, but by default, this function is doing, I think it's 1 of 4 or 6 mbar as the manual recommends, excuse me. So from there, I am updating my adjusted flags that they're 1 if they were 3, because I've had a look at them. But then I do go back and I should review this step because there's some conversation during a previous presentation about what the salinity flags were in relation to the DOXY flags. I'm treating, if salinity is 4, then DOXY should be 3 as a hard and fast rule in this case. But like I said, I was reminded that as the operator, I can sort of overrule that if I wish, if the oxygen looks good despite salinity being bad. And so I might take a second look at that. And then down here, this is something that satisfies the file checker, which thank God for the file checker. I'll talk more about that in a bit. But for adjusted values, the file checker doesn't like if you have not the fill value in there. If an adjusted value is bad, then it shouldn't even really be there. So I'm removing values from deoxy adjusted and deoxy adjusted error where those values are bad. And then I want to go and I want to put it on the GDAC, and so I say export files, and it will do all of this for me. Clearly, there's a lot going on in the background there. If you've tried to, I find working with NetCDFs to be challenging and sometimes frustrating. But I mean, there's a good reason for that. The Argo dataset is, like very consistent and nice. And if this wasn't, maybe challenging, then we might have a mess of a data system. And so I've worked very hard on this, that it's now producing files that are, compliant with the file checker, and they can be piped right off to the GDAC when they're ready. Yes.
Chris, Annie Wong has her hand up. I don't know, Annie.
Okay. Yeah.
Now or.
Oh, Chris, I really like your Python package. I'm curious about your update field function. Can you use that to flag single points?
Yeah. So
how does that work?
Again, this is where it's maybe a little bit clunky for now, but as long as you can define where the point is. So I'm using a lot of these sort of big arrays of Booleans to define, if it's 0, 1, or 2, make it this. But if you just knew the index or a way to point to a single point, you can update a single point with that, as long as you can define this where variable to tell it where to reassign a value, basically. Yeah.
All right. So it's not fully interactive yet. It's
not yeah.
Okay. Got it.
Yeah. What I would like to do eventually is sort of at this stage, to open up a plot and say, even if it's it could be a single profile, or if I just click on this point, it could return a value that I could put in that where argument. That's kind of my vision for it, is if I opened up an interactive window, click on this and say, okay, I'm done, and then assign that with the update field.
Yeah, that's what I'm trying to do too. So if you get there, I'd like to know, Chris.
Sure. Yeah, definitely. So yeah, like I said, there's a lot that goes into exporting a demode file. There's a certain amount of information that clearly I'm not doing this manually, and so it must be happening in here. But there's also information about me or about the user that is required. And so what I've done is I've made this configure function that's on the right, and that's good for a lot of things. And so I would suggest setting this up if you were to download it and start using it just right away. And unless you change something, you'll kind of only have to do it once. And so if you install the package and then import it, you can choose where you're going to put your Argo data, and you would define that with Argo path, your reference data with this. I am the DMQC operator, so I put that here, what my affiliation is. Some other information that I should have showed that isn't here, the 2-letter code for your DAC that goes into history variables within the NetCDF file. We could talk all about, you know, for anyone that wanted to look more closely at the D mode export, I'm happy to go through that functionality with you. But what that allows you to do is if you do, oh, sorry. So this just shows, this is where I keep my data, but like it could be anywhere, but this is what it looks like. One thing I'll mention about the Argo data is that it should be downloaded such that there's a DAC folder. That shouldn't be too challenging. That felt natural because that's the way it is on the GDAC, and that's the nice way to look for data, in my opinion. My ANSET data is as it comes off of the site, and yeah, so there's some tools to download those. But what's nice about it is it ends up okay. I've said okay, let's get one of these D mode files that I've exported, and because the Python package knows who I am and where I'm from and so on, and it knows how it got to the game. Then it just automatically fills in my scientific calibration comment in this way, as well as other, you know, similar sort of metadata fields that go along with it. Yeah, and then I'll say it again. Thank goodness for the file checker. If you've attended an ADMT, there's no shortage of praise for it, and I just want to echo that again. It's an invaluable tool. Yeah, quick comparison to Sage. These are actually quite old plots. I haven't done it in a while, but also you know, the WA and the interpolation and so on hasn't changed too much. There tend to be some small differences. What I think at this point are mostly numerical differences between the two on either if like they're crazy gains, which are you know, pretty reasonable. Like I'm not too worried about this outlier point that like one of the gains is 1.5 and the other one's 0.5, because it's something's wrong there, and you would be looking at that more closely. But that most of the sort of difference between the MATLAB software and my package tends to be just some small differences in the interpolation of the World Ocean Atlas. I've tried to pinpoint it, but also it's not worrying me too much. There is an issue that maybe I didn't link, but I've done quite an extensive comparison if it's something that you want to take a look at. And basically between my own running of Sage and comparing it to the Python package, as well as comparison of the gains that I get from the Python package to the Oxygen audit, there's quite good agreement between the two. So
Chris, can I ask in those comparisons, how many floats and which floats from the variety?
So the ones where I'm comparing them more directly to the software, I probably should up that population because it's mostly been on Canadian floats because I do it sort of as I go. Basically, until I'm absolutely confident in this, I've been essentially running Sage in parallel once I'm done, just to make sure that the gains look the same before I do anything to the floats that I'm actively trying to DMQC. But for the I could actually just switch over to it. Can you see an internet browser now?
Yeah.
But for like comparison to the audit, if I go to the latest, the last time I ran this, we could see. So I'm treating because the floating point number in the audit is, you know, 2 decimal places, I'm treating that as perfect. So we get like perfect agreement for, or near perfect agreement for a few thousand, and then there's and then yeah, so I guess this yellow and red area of the bar plot, there's a few hundred out of 5,400 floats that have enough difference that if I was DMQCing a float, you know, actively, and I saw that much of a difference, that I think they're different enough to merit investigation. But also these, you know, the qualifier to that is these could be some quite bad gains, like I said before, So yeah. Is that good?
Yeah, yeah.
Answers? Yeah, okay. Yeah, so maybe I'll stop there. I'm going to mention this float really shortly just because maybe we could come back to it tomorrow but I thought I would throw it in here because I have the stage and it's in the oxygen audit and I'm trying to resolve all those floats right now. Just sort of an interesting looking one. Something bad happens to salinity, and around the same time, there's a big shift in oxygen. And my question for the group would be, you know, things look quite good before this shift. And even after this shift, I would argue things look like they're probably salvageable, but sort of a question to the group and sort of, I guess, what would you do in this situation? I'm tempted to, you know, throw a breakpoint here and do a different one gain over here and another gain over here. The gain over here is basically 1. And so maybe just something else on this side, but something we could come back to in the more when it's more appropriate, but I thought I would put it up here. So wrapping up, I have this package used to calculate gain, visualize data, export to delayed mode. The in-air definitely needs some attention. I'm definitely not ready for trajectory 3.2 files, and even on some older ones, I'm still running into just some issues the way that I load those in. But it's that in particular is quite at the top of my list to fix about it. Good agreement with stage. Some functions I didn't talk about today because they're a little less relevant, but do exist within the package. You can do time response correction, various oxygen unit conversions. There's a function where if you have ship data, you can sort of add it to your float object and then compare those two. And then some things in the pipeline of varying priorities would be interactive plotting, like we talked about. Despite that, I'm quite happy with the D mode export now. It definitely needs some better documentation on my end and descriptions of if you were going to pick up this package and use it for yourself, how would you get that up and running, and what would you need to configure? The file handling, that's more of an internal thing, but it's something that I think I wrote myself originally, and there are better packages out there for it now, namely ArgoPy, and so I'm going to look at how that could sort of synthesize in there. Gain with carryover is on my list. Breakpoints and yeah, so lots of, it's a long to-do list, but like I said, some more important than others. So I'll maybe stop there. Well, I'll stop there at the end of the presentation. Thank you. And I will, if we're behind it all, I can jump into the chat and try to answer questions from there if we want to move on.
I think there's a few questions in the Slack.
Okay.
You want me to read them?
No, it's okay. I've got it here now.
Brian and Camilla.
That's awesome. Yeah, so Brian's comment, I think, yeah, it sort of goes with the conversation before that, you know, the more we refine the way that we calculate gain, not necessarily with just a blanket mean value, will probably improve, you know, some seasonal signals that are still making it through or not making it through, but perhaps causing bias. It is, so for Camilla's question, is it just calculating and applying mean gain? Yes, it is calculating the mean gain. If you had like it, I don't have any functions that do the you know, like the in-situ drift calculation. If you had that yourself or had defined that yourself, it would be, I would have to maybe think about it a little bit, but it would be reasonably straightforward to use the update field function to, you know, if you had a vector of gains and to update cycle by cycle appropriately for export later. Josh, about filling the B file, that's a good point, actually. So it does fill in the delayed mode file when, so basically it gets the gain from the synthetic profile, but as you're making delayed mode files, it's using the BR file to populate the DOXY adjusted. Yeah. Giorgio, yes, have thought about ArgoPy, as I mentioned on the conclusion slide. Yes, I was working on these slides up until very much the 11th hour, but they are on the drive now.
Chris, Brian also made a comment about the float with the failed salinity, which I was going to comment on too. And we really need to be careful. I want to emphasize the point that with catastrophic salinity failure, particularly when you're using, you know, climatology to calculate the gain, you really need to first reprocess your profile data with some sort of salinity proxy. We've talked about the RMFP as a potential prior to rerunning an assessment. So that would be, I think, kind of yeah.
yeah, that's a good point. Yeah, it's the break is definitely because my calculation of percent saturation is breaking because of the salinity. Yeah, that's right.
And also, yeah, I just want to second. Thanks for presenting, and of your software are really great. I think the interactive flagging once you get that buttoned up would be an awesome to have. Yeah, thanks a lot.
Thanks.